Hey, hi, Rajan this. I welcome to the channel. So today we will discuss all four problems asked in today's LeetCode Biweekly Contest 169. Let's start with the first problem. It says you are given an integer array nums, and in one move you may increase the value of any single element by 1, and we have to find out the minimum total number of moves required so that all element of nums become equal, right? So we have to make all the elements of the given array to the equal value. So like for example here 2 1 3, if you want to make all elements equal, since if you observe it here, you can only increase the number, right? If you can only increase the number, then the minimum number of moves that would be required is to make all the numbers equal to the maximum element. For example here if you see 2 1 3, the minimum number of moves would be required if you make all the elements equals to 3. So to convert 2 to 3 you would need one move, and to convert 1 to 3 you would need two moves. So in total you have to make three number of moves, 2 plus 1. And let's take this example here 4 4 5. If you want to make all the elements equal, just make all the elements equal to the max number, right? So you have 4 and 4, so to convert 4 to 5 you need one move. So one move for this one and one move for this one. So in total two number of moves, right? So yeah, this problem is pretty easy. Let's directly look at the code. Here is the code of first problem. So you are given nums array, just find the maximum element, right? And this is the minimum number of moves that would be required. So just go through all the numbers in the given array nums and just do moves plus equals to max minus this current number, right? So whatever number of moves you would need to convert x to that max number, that would be added in the moves variable, and at then return this moves, right? So yeah, this is all about the first problem. Now let's look at the second problem. In second problem, you are given integer array nums and an integer target, and we have to find out the number of subarray in which target is a majority element, and a majority element is the one that appears more than half of the times of that subarray, right? And we know what is subarray. So let's take this example. In this example, your nums array is 1 2 2 3 and the target integer is 2. If you see, there are 5 subarray in which 2 is a majority element. One is this subarray, other one is this one, the third one is 1 to 2. If you see this one, so here the size is 2, right? So the half of the half is 1. So for the number to be majority element, its frequency has to be at least 2, and if you see, the frequency of 2 is 2 here. So this is one of the majority element, like in the subarray. This is one of the subarray where 2 is majority element. And 0 to 2, if you see, this is also majority element. This is interesting. If you see, the size is 3 divided by 2 is 1, right? So the if the number has to be majority element, its frequency has to be more than 1, means at least 2. If you see, frequency of 2 is 2 here. So this is also one of the majority subarray. And similarly from index number 1 to 3, right? Yeah, this problem is pretty good. Let's see how we can approach it. In second problem, we have to find out the number of subarray in which target is a majority element, right? So let's take an example. Let's say this is my given array, right? This is my given array. Index is from 0 1 2 and up till n minus 1, right? Let's say I'm considering this subarray. Let's say the left index is I and the right index is j. Let's say I'm saying that this subarray from index I to j is a subarray in which target is a majority element. So what we can do, we can find out the count of target in this subarray. Let's say that count is target count, right? Target count, right? So target count would tell you the count of the target in this subarray. And if I'm saying that this target integer is a majority element in this subarray from I to j, what it means? This target count has to be more than len divided by 2. This length is nothing but the length of this subarray. And what is this length? Length is nothing but j minus I plus 1. So if you have a subarray from index I to j, its length is j minus I plus 1. And so if your target count is more than length divided by 2, it means that this subarray contains the target integer as a majority element, right? So since your n is only up to 10 to the power 3, right? So 1000. So we can easily apply a order of n square solution. What we can do, we can go through each possible subarray, right? So let's say I am having one index for I and that index is from 0 to n minus 1. And let's say I have another the right index, like the left index is I and the right index is j, that is from I to n minus 1, right? So this is my I, this is my j, right? What we can do, we can find out this target count, and we can just check if the target count is more than length divided by 2, means that n for plus plus, right? The number of subarray, like you found a subarray in which target is a majority element. So in this solution, the only job is to find out target count, right? So how to optimistically find the frequency of target in any subarray. Because if you start doing again a for loop, right, so it would be order of n cube solution. So order of n cube won't be accepted. You must have order of n square solution at max, right? So we have to find out this target count in order of 1. And for that, what we can do, we can apply a prefix sum concept. I would highly recommend to go through prefix array or prefix sum concept in an online tutorial. So let's say I build a prefix count vector, right, where prefix count of I would tell you the number of times target variable, this target element appears in subarray from index 0 to I, right? So let's say that is stored in prefix count of I, and if you build this prefix count for all the for all the index from 0 to n minus 1, so it would be a vector, or integer or vector, you call it, of prefix, let's call it prefix count, and its size would be n, right? So we will build this prefix count for all the index 0 to I, and let's say prefix count of I is the number of times target appears in the subarray 0 to I. If you build this if you build this prefix array, you can easily find out the target count like in the subarray from I to j. So for subarray I to j, your target count will be this prefix count of j minus prefix count of I minus 1, right? This is how you would build how you will get the target count. So yeah, I mean, this concept is, I mean, it's very useful concept. I have seen almost each and every problem in the LeetCode that you would use this prefix array or prefix sum concept. So please learn it. I mean, it's pretty easy. Like I'll explain it in the code, then you would understand it if you are kind of reading it for the first time, right? So, but to get the concept pretty strong, you have to learn it through any online tutorial, right? So yeah, let's look at the code now. Here is the code of second problem. So as I mentioned, you would be given nums array and the target. So this is this size. I have created one prefix array. So this array is so I have called it prefix count. This prefix count of I essentially tell you the number of time target appears in the subarray 0 to I. Let me call it prefix of I is nothing but number of time target appears in subarray 0 to I, right? So what is my prefix count of 0? That is nothing but, like, if your num of 0 is target, then it would be 1, otherwise 0. And for index I to I is equal to 1 to n, your prefix count of I is nothing but prefix count of I minus 1, right? The previous prefix count plus your current number. Like if your current number is target, then it would be added by 1, otherwise 0, right? I hope you understand this part. This part is so this comes from the prefix array concept. Now let's come to the answer. Now what we do, we will go through each possible subarray. So for I is equal to 0, I less than n, I plus plus, j equals to I, j less than n, j plus plus. So it will tell you all subarray from I to j, right? So this is subarray from index I to j. Now what its length? The length of this subarray is j minus I plus 1, like as explained in the explanation part. And what is my target count? Your target count is nothing but prefix count of j minus prefix count of I minus 1. Like, so just check if your I is valid or not. If it's invalid, like if your I is 0, then I minus 1 won't exist, right? So that's why your subtraction is 0. Otherwise, prefix count of j minus prefix count of I minus 1. This is my target count and this is my half of the size, len divided by 2. So just check if your target count is more than half. If it is more than half, it means that this target element is a majority in this subarray from I to Z. So just update your answer. You do answer plus plus and at the end return the answer. Right? So yeah, this is all about the second problem. Now let's look at the third problem. In third problem, you are given integer array terms and you are allowed to replace at most one element in the array with any integer of your choice. And you have to find out the length of longest non-decreasing subarray that can be obtained after performing at most one replacement, right? So you have to find out the longest non-decreasing subarray after performing at most one operation, and this operation is that you just replace any of the number to any of the number of your choice, right? And we know what is subarray and what is non-decreasing, right? So for example, let's say this is my subarray 1 2 3 1 2, right? So if you don't apply any operation, what is your maximum non-decreasing subarray? 3, right? 1 2 and 3, the length is 3. But what if you just change this 1 2 3, then what will happen? Like if you change this 1 to either 3 4 5 or any of the number, like which is at least 3, then your size would be 1 2 3. So let's say I change it to 3. So if you do that, your longest non-decreasing subarray would be 4, then 1 2 3 and 3 after replacement, right? So your answer is 4 in this case. See here anyway, your maximum non-decreasing subarray is anyway 5. So even if you do apply operation, your maximum length is not going to change, right? So yeah. This problem is kind of DP plus prefix array concept. So yeah, it's a good problem. Let's see how we can approach it. In problem number 3, we have to find out the length of longest non-decreasing subarray after doing the replacement process at most one number of times, right? And the replacement is like you can change any number to any number of your choice, right? So we will solve this problem using dynamic programming concept. Not a dynamic programming, it's a basic dynamic programming, or you can also call it prefix or suffix array concept. So here what we will do, we will create two dp vector. Let's say I call it dpl, right? So dp for left and similarly dpr, both are size n. So here dpl of I is nothing but maximum length of non-decreasing subarray, the maximum length of non-decreasing subarray that ends at index I in subarray 0 to I. In subarray 0 to I. So yeah, I'll explain it. And similarly dpr of I is nothing but maximum length of non-decreasing subarray that starts at index I in subarray I to n minus 1. I'll tell you what this dp of l, I and r means. Let's say this is my given array, right? So this is my given array from index 0 to n minus 1. Let's say I'm at any index I. So here what is your dpl of I? dpl of I is nothing but the maximum non-decreasing subarray that ends at index I in the subarray 0 to I. Let's take one example. Let's say the example is 1 2 3 4. Again let's say 1 2. Let's say this is my index I. If you see here, this is my I, and in the subarray 0 to I, right? So this is my index 0 1 2. Again this is 3, this is 4, and this is 5. So let's say this is my I. I want to find out what is dpl of I. dpl of I is nothing but maximum length of non-decreasing subarray that ends at index I and in the subarray 0 to I. See, what is your dp of l of I? That is nothing but 4. 1 2 3 and 4, right? It's completely non-decreasing. Let's take another example. 1 2 1 2 for example, and this is my I. I want to find out what is the length of longest maximum length of non-decreasing subarray that ends at index I in the subarray 0 to I. If you see here the answer is 2, only 2. Your subarray must ends at index I, and what is the maximum length of non-decreasing subarray? If you see, the length is 2. If you include 2 and 2, 2 and 2 is not a non-decreasing subarray, right? Because this is 2, 1 and 2. Like in non-decreasing, it has to be in increasing order, right? Or constant order. So here the answer is 2. So I hope you understand what is dp of L of I. And for dpr of I, dp of r I nothing but maximum length of non-decreasing subarray that starts at index I in subarray I to n minus 1. Let's try to understand that by taking some example. I would highly recommend to learn at least prefix or suffix array concept, because this is pretty much similar to that. So let's take one example: 1 2 3 1 2, or again let's say 1 2 3 1 2 3. What is, let's say this is my index I want to find out dpr of dpr of that index I. What is dpr of I want to find out the maximum length of non-decreasing subarray that start at index I, right? Starting from that index, what is the maximum length you can go first that the array is non-decreasing? This, since this is the last element, so it's anyway 2, right? For this one. Now let's take another example. Let's say let's say your I is, for example here, not 3, let's say the I is here, I is 2. I want to find out dpr for this index 2. What is dpr for? I want to find out the maximum length of non-decreasing subarray that start from this index I in the subarray I2 n minus 1, right? See, let's see how long you can go. 2 3 then 1, so only 2. Similarly for 1, let's see how long you can go. So here the answer is 2 for this index. Let's say I want to find out for this index. See, 1 2 3 then decreased, so here the length is 3. So your dpr of I is nothing but 3. So yeah, I hope you understand what is dpl of I and dpr of I, right? So we can like easily build this dpl and dp of r. So let's say for any index I want to build the dpl of I, right? So if this number at index I is greater than or equals to a of I minus 1, right? If this number is more than or equals to the previous number, then dpl of I is nothing but what is my dpl of I minus 1? What is the maximum length of non-decreasing subarray at index I minus 1? Then I can append this number, right? So plus 1. Otherwise your dpl of I is nothing but 1. Because let's take an example. Let's say my previous number was 5 and my current number is 1. So what is dpl of this index? That is 1, right? Because like, see how long you can go in the previous direction, like in the reverse direction, in the left direction, such that your subarray that ends at index I is a non-decreasing. See, only one, because if you include 5 1, this is not a non-decreasing subarray. So yeah, I hope like you have solved at least one dynamic programming problem. So I mean, the main goal of this video tutorial is to explain the solution of the problem asked in the contest, not everything. Like, I cannot explain everything needed in this like to solve this problem in the contest. You have to learn it by yourself. You have to like spend some time to figure it out. I mean, how the algorithm works. So here I'll explain you how to apply the algorithm, but not the algorithm. So for that I'll create a separate video, right? So yeah, this is how you build dp of L, and similarly in the reverse direction you can build dp of R. So if you know dp of L and dp of R, the job is pretty easy. The problem is almost solved. Let's say I want to replace this index, right? I want to replace the number that is present at index I. If you want to replace this number, your subarray in the right side is untouched, right? That will be as it is. So that would be from index I plus 1 to n minus 1. Similarly, since you can apply at most one operation, your left subarray, your prefix array would also be as it is, right? The index is I minus 1 and this is index is 0. And I want to replace this number. If I want to replace only this number, see what are the options you can get. Let's say you have some maximum answer, like for example, your max answer is going to be maximum of mx. Let's say I'm calling it, let's say I call it mx. Mx is equal to maximum of mx, comma. See, I can replace this number to any of the number of my choice. What if I replace this number to, so let's say the number that is present at this index is x. Let's say I replace this I to x plus 1. Then this will also be a non-decreasing subarray, right? So the options are your mx is equal to maximum of answer, comma, dpl of I minus 1 plus 1, right? I can easily change this I to this 1 plus 1 extra number, right? Similarly, I can also replace this I to, so let's say this number is y. I can also replace this number to y minus 1, right? I can like easily replace this number to y minus 1. If you replace this number to y minus 1, this will also be a increasing, I mean increasing means non-decreasing subarray. So your answer is also dpr of I plus 1 plus 1. Right? So these are the options you have. You can easily convert this number to any number. If you replace this number to previous number plus 1, then this is the choice you get. If you replace this number to the next number minus 1, then these are the choices you have. But there is one more interesting choice. What if this number, this x is, let's say this number x, right? If this number x is less than or equals to y, see, you can do a magic here. If this number is originally x is less than or equals to y, you can easily replace this number to either x or y, and you can make a complete array as a non-decreasing. So in that situation, if this x is less than or equals to y, your mx is your answer, for example, for this is nothing but your answer. Your maximum length can also be max of mx, comma, dpl of I minus 1 plus dpr of I plus 1 plus 1, right? See, what is dpl of I minus 1? Give me the maximum length of non-decreasing subarray at the previous index, this, plus dpr, so give me the length of the maximum length of non-decreasing subarray at index I plus 1. And since if your x is less than or equals to y, we can easily make this complete subarray as a maximum non-decreasing subarray, right? So just check if your x is less than or equals to y. If that's true, just update your answer. Your max mx is going to be maximum of mx, comma, this plus 1. I can make complete subarray as a maximum non-decreasing subarray, right? So yeah, this is all about the explanation part. Let's look at the code. This is my nums array, this is my size, this is my dpl, dp of r as per the explanation part. I have built it as per my explanation. So dpl of 0 is nothing but 1, like the subarray size is 1. And for index I to n, just check if your current number is more than or equals to previous number. If that's true, your dpl of I is nothing but dpl of I minus 1 plus 1. Otherwise, dp of l of I is equals to 1. Similarly, for the right dpr of n minus 1 is equal to 1, and for index n minus 2 to 0, you can just check if your current number is less than or equals to previous number, next number, then dp of r of I is dpr of I plus 1 plus 1. Otherwise, dpr of I is equal to 1. So this will build the dpl and dp of r. Now this is my answer, maximum subarray length. Now here what I'm doing, I'm trying to replace the current number, right? The current number. So for that, what I have done, I have first find out dp of l and I minus dpl of I minus 1, like the previous dp, and the next index dp I have stored into left and right variable. So like for the choices we have is, well, so one of the choices is left plus 1 and right plus 1 as per the explanation part. And the other choice is that if your the number that is present at index I minus 1, if that number is less than or equals to this number, then you can easily make the complete array as a non-decreasing subarray. So there is one more choice you get, that is left plus right plus 1, right? So we can easily convert current number to either x or y. It's up to you. I mean, so either choice you have, you would anyway make the complete array as a subarray. So just update your answer. So yeah, at the end return your maximum answer, right? So yeah, this is all about the explanation part. Like, I know this problem is not that straightforward, so if you have any difficulty in any of the line or anywhere, just try to comment. I'll resolve it, right? So yeah, this is all about the third problem. Now let's look at the fourth problem. This fourth problem is same as the second problem. The difficulty comes only in the constraint part. So in the second problem, the constraint was that your max length can go only up to 1000, right? So we easily applied order of n square solution, but here we cannot apply order of n square solution. So we have to find out some order of n log n and order of n solution. So the problem statement is exactly the same. You are given integer array nums and target, and we have to find out the number of sub array in which target is a majority element, right? So yeah, I'll post a video of the fourth problem in a separate video. So in this video we have a q1, q2, q3 solution. q4 is just coming in 10 or 15 minutes, right? So just wait and I'll post the solution for the fourth problem. I'm currently making the video for it, so it would take some time. That's why I'm posting the video for first three problem first. Yeah. If you find the video helpful, please like, share and subscribe to my channel. Thanks for watching.